everyone. Whoops. I just wanted to do a quick, there we go, a quick summary video of what things you should have noticed about this graph of y equals k over x when you looked at it on the Desmos website. So I wouldn't recommend watching this video before you work your way through that activity, which is also linked in Blackboard for you. As I kind of talk my way through these properties, it would probably be a good idea for you to have your table out, okay? And you can be filling in the information into your table. This is in your notes while I'm kind of talking through it, because these will be the things that I'm talking about. But I just wanted a big picture of the graph here. So this is what you should have seen when you looked at this picture, okay? Anything that's something divided by x is going to give you this crazy picture. This is probably the first time you've seen a graph that is discontinuous, meaning it's in two separate pieces. But that is how this graph works, okay? The pieces should actually look more symmetrical than they are. Okay, I just did a bad job drawing this one. But these are called the two branches of the hyperbola. So the name of this graph is a hyperbola, not hyperbola, hyperbola, okay? And this graph has some pretty unique properties that you maybe have not seen in other graphs before, so I want to take a minute and talk through them. The first one is these graphs have what's called an asymptote. And if you want to pause the video quick and make sure that you have this word written down, that wouldn't be a terrible idea. An asymptote, this was in yesterday's notes. We wrote down this definition. An asymptote is a line that a graph approaches but never touches. So if you need that, feel free to pause right now and get that jotted down. I always refer to the asymptotes as like the electric fence, okay? And you'll notice this graph has two of them. See this right here? Okay. My graph is going to get closer and closer and closer to that vertical line up here and down here, but it's never going to touch it, okay? Similarly, and that line, by the way, would be the line x equals 0. If you think about how we name lines in algebra, x equals 0 would be that vertical line up the center. So that's one of our asymptotes. The other one is a horizontal line that runs this way, okay? And that would be the line y equals 0. So I would say for this graph, we should know that it has asymptotes at x equals 0 and y equals 0. I do realize that I don't have a place in the table for that information, but you will want to know it, okay? That is going to be important for you to know. So you can write that down maybe someplace else in your notes, somewhere where it makes sense to you. But it has asymptotes at x equals 0, y equals 0. The reason for this asymptote is because we know that we can't ever plug a 0 in for x. We can't ever let x be 0, and so we get this gap in our graph. We can plug in things that are very close to 0, like 0.0001, okay, and we're going to get something, you know, pretty tiny. But or we can plug in a negative 0.0001, but I can never plug in 0 itself. And then similarly, because I'm always going to have a number up there for k, I can never get 0 out as an answer, because the only way I could get 0 out as an answer is if I put a 0 up there, and the 0 up there would just cancel with the x, and then I wouldn't even have a hyperbola anymore. Okay, so that's where these two asymptotes come from, x equals 0, y equals 0. That leads pretty directly into my domain and range. Okay, my domain here is what x values can you have? And you'll notice that this graph stretches out forever to the left and to the right, but it just doesn't cover that 0 in the middle. And so I would say my domain is everything except 0. And then same thing for my range. This guy goes up forever, this guy goes down forever, so we cover everything up and down. What we don't cover is 0 itself. Okay? And if we're never crossing the x-axis and y-axis, then we don't have any intercepts. This particular graph does not have intercepts of any kind. Okay? No intercepts. All right. I think the most interesting part of this graph, though, is the limits. There at the end of your table. And these were the things we talked about yesterday, where we said as x approaches infinity and x approaches negative infinity, what's happening to your graph. And yesterday, all of the ones we looked at either went up forever or went down forever, right? They always approached infinity. But look at this one. As you walk out towards infinity in this direction, what is happening to the tail end of this graph? Where is it going? Well, it's getting closer and closer and closer to that middle line, which is 0. So we're going to say y approaches 0. It doesn't actually reach it because it can't reach it. It's got an asymptote there, but it gets closer and closer and closer to 0. This one does the same thing. Okay, this one, as you walk out to the left, is going to get closer and closer and closer to 0. It's just getting closer from the other side. It's getting closer from the bottom instead of from the top, but it's still approaching 0. Now, the only other thing that we didn't really look at is how does this graph change if I decide to make my k value negative? And I'm hoping you've kind of seen a pattern here that with all of our graphs, when we make our k value negative, what it really does is flip it upside down. It flips it vertically. And so what's going to happen here is your branches are just going to switch to the opposite quadrants. Okay? So I'm going to draw this in here and this in here. Kind of ignore the red for right now. Okay? And so this green represents when k is negative. Okay? Then it shifts so that it's in quadrants 2 and 4 instead of 1 and 3. Okay? That really doesn't change much about the graph. You still have asymptotes in the same places, okay? Which means your domain and range and your intercepts, none of that changes. And even your limits stay exactly the same because this is still approaching 0. Again, it's just approaching from underneath. And this one is approaching from above. So when you have a negative k value, your hyperbola is going to switch to these two corners instead of these two. And you will have to know the difference between those two. But none of your properties change. So as far as your table goes, you can just go ahead and fill in the exact same thing. Okay, the one other thing that we needed to talk about right at the end of your activity, I told you to go back to your equation y equals k over x and just stick a square on that x. And I'm going to draw it for you in a second, but I want you to see what happens there. When you square the x, what it's going to do is take all of these negative y values, and because they're being squared, it's going to turn them positive. It's going to flip up here. This one's going to stay where it's at, and this one's going to flip upstairs. So when you went ahead and put that square in on your graph, it should have come out, whoops, oh man, now I'm on the spot to draw this nicely. Okay. It should have come out looking like a hyperbola here, but it ended up being side by side like this. Okay? This guy is the graph of y equals k over x squared. So when I square that x, all it did was take my branch of the hyperbola that was down here and flip it up top. Okay? So that would be the lower level of that table that you're filling in. Notice you still have asymptotes in the same places. You still have this gap in the middle here. And you still have asymptotes here. It's just that both of your branches are up above there. Okay? So as far as this information goes, I'm just going to be a little bit lazy here and take this from what we just said. There we go. Our asymptotes are still at x equals 0, y equals 0. Our domain is still everything except 0, because x-wise, you're covering everything except 0 in the middle. Except now your range, so when k is negative, your range is going to be all real numbers above 0. Okay? Because notice both of your red branches here are up above 0. You no longer have anything heading downward, okay? So we can't just say it's all real numbers except 0 because now this branch of the graph is up here, okay? So it's everything above 0. Notice I didn't do the equal sign because it's not actually touching 0. It's still true that we don't have any intercepts, and our limits are still the same because as I work out towards infinity, both of these things are still just getting closer and closer to 0. So as far as differences in your properties, This is the only thing that changes when you have the k over x squared. Okay? By the way, if I take that k over x squared and I make my k value negative, okay, just like with all the other graphs, what it's really going to do is flip this thing upside down. So it's going to give you side-by-side ones, but they'll be down here. Okay? I'm going to kind of leave it to you to figure out how all that information applies to your table. Okay, so I should have just covered just about everything that should go in your table, or I at least alluded to it. There may be some places that you have to think for yourself a little bit. But you now should be able to fill in these bottom 2 rows in your table, okay? Paying careful attention to any differences between k being positive and k being negative. You will want that information filled in before you start your homework for tonight, which is Lesson Master 2-6B. Okay, we will be sure to go over all of this stuff together when I see you again on Wednesday.